Hello everyone, I am Srinivas. Welcome to my channel. Guys, now we are in class 12 of the chapter Heat, and in this class we are going to discuss about boiling. Let's get started. Yes, please subscribe to my channel. Do like the video and also share the video. For new notifications, click on the bell icon. In our class of phase changes, I told you that boiling is a conversion of liquid phase to the gaseous phase, and evaporation also refers to the conversion of liquid phase to the gaseous phase. But what is the difference between evaporation and boiling? So to understand boiling, let us do a simple activity. For this, you need to take a beaker with water at room temperature. Now heat the water using a burner, and with the help of a thermometer, record the temperature of water for every minute continuously. So in the figure you can see, I am taking water in this beaker, and with the help of burner I am heating this water. With the help of a thermometer I am measuring the temperature, and I am continuously recording the temperature. If possible, try to draw a graph between the time and the temperature. In our next slide, I will show you the graph between time and temperature. We can observe that the temperature of water slowly increases and reaches 100 degrees Celsius. After that, we cannot see any change in the reading of thermometer even we are supplying the heat. Guys, if we are doing this activity in our laboratory, if initially we take the water from example a temperature of 40 degree, then when we started heating the water, its temperature slowly rises from 40, and after certain time it reaches 100 degrees. But once it reaches 100 degrees, even though we are supplying the heat energy, we cannot see any change in the temperature of the thermometer. So the temperature is fixed at 100 degrees. So why is it so? Let us understand. So this is the graph between the time and temperature. So initially we are taking the water from room temperature. So on x-axis we are taking the temperature and also the heat supplied. On y-axis the temperature of the water. We are recording for every minute, no? So I am drawing the time versus temperature graph. So initially when we take the water, we are taking the water from room temperature. So for the first minute, so let us assume the room temperature at 40. So for the first minute, it may reaches 45. And for the second minute, it will be reaches 50. Like that, slowly the temperature has raised to 100 degrees. So from 40 degree, the temperature slowly raised to 100 degrees. And after 100, we cannot see any change. The temperature is constant. It is not changing as the time is in progress. But here we are supplying the heat, but there is no change in this temperature. Okay, I hope you understand. But why is this temperature constant here? Even though we are supplying the heat energy, why not the temperature is changing? Where does the heat supplied go? What changes do you observe in the water when temperature is 100 degrees Celsius? Now, we can observe when the temperature of the water reaches 100 degrees, some bubbles are coming out of the water. Water starts bubbling. What is the reason for the bubbles in the water? Guys, water is a solution. Solution means mixture of many things, okay? So in the water, we cannot see the ions, dissolved salts, dissolved gases like that. So water is a solution, and in this water we are having so many things dissolved. So many impurities dissolved in it, like some gases, some ions, some salts. Like that, there are so many things which are mixed in the water, and hence water is a solution. When water or any liquid is heated, then solubility of gases it contains reduces. As a result, bubbles of gas are formed in the liquid at the bottom and on walls of the vessel. So actually there are some gases which are dissolved in the solution, that is water. When we are heating, the temperature of the water is rising. When the liquid temperature rises, the gases which are soluble, the solubility will decreases and they will come out of the liquid. So as we are heating the water, the temperature of water is increasing, the solubility of the dissolved gases reduces, and the gases will come out. That is what we are seeing in the form of the bubbles. Okay. Evaporation of water molecules from the surrounding causes these bubbles to become filled with saturated vapor, whose pressure increases as we increase the temperature of the liquid by heating. So, consider this is the container we are using for boiling. So, up to this level, let us assume we are having the water and we are heating this water. Okay, as we are heating, the temperature is increasing, solubility of the gases decreases, and it is coming out in the form of bubble, right? So, let us consider. So, here this circle is a bubble. Okay, consider this is a bubble. Okay, this is a bubble. So bubble means it is a gas, right? So it is all air inside the bubble. Now what happens in the surroundings? Okay, in the surroundings of this bubble, what happens is that because of rising in the temperature of water, it gets converted to steam, that is gas, and enters into this bubble. Okay, so here water is evaporated, water is converted to gaseous form. This liquid is converted to gaseous form and enters into this bubble. Okay. So this water vapor we can call as saturated vapor. Okay. If we just compress this vapor, it immediately turns to liquid. That is what saturated vapor is. So the surrounding water of this bubble will get evaporated and that saturated vapor enters into this bubble. And as we are heating, the temperature going up, so that the vapor entering the bubble is increasing, which raises the pressure inside this bubble. Okay. At a certain temperature, the pressure of saturated vapor inside the bubbles becomes equal to the pressure exerted to the bubble from the outside. So here, so this is the bubble. So saturated vapor is entering into the bubble, and as a result, pressure is increasing inside the bubble. There is some pressure which is outside the bubble also. What is that pressure? So here, this is the atmospheric pressure, and this is the layer of water which is above this bubble. So this total is the pressure outside the bubble. So inside the bubble, there is pressure due to the saturated vapor, and outside the bubble there is pressure due to the atmosphere as well as this layer of water which is above this bubble. Okay, so slowly as the temperature is rising, saturated vapor in the bubble increases as well as the pressure inside the bubble increases. And at a certain temperature, what happens? As the pressure inside the bubble is increasing, at one particular time, whatever the pressure inside the bubble will equals to the pressure outside the bubble, which is nothing but the atmospheric pressure plus the pressure of the water layer above the bubble. Then what happens? The bubble rises rapidly to the surface and collapses at the surface, releasing vapor present in bubble into air at the surface. So initially the bubble is at the bottom as the pressure is increasing, and when the pressure inside this bubble equals the pressure outside the bubble, then this bubble will rises to the surface of the water, and at the surface this bubble will collapse. When the bubble collapses, the saturated vapor which is present inside this bubble will be released outside to the atmosphere. Okay, so when the bubble breaks, the inside vapor will be released to the atmosphere. So in this form, the liquid, that is water, is converted to the gaseous form with the phenomena of bubbling. So this whole phenomenon you can call as boiling. Okay, the process of converting the liquid into vapor continues as long as you supply the heat. This appears as boiling of water for us. Okay. Boiling is a process in which the liquid phase changes to gaseous phase at a constant temperature. So this constant temperature is nothing but boiling point. Okay. That is the boiling point of the liquid. So in this case, for water at normal atmospheric pressure, the boiling point is 100 degrees Celsius. For another liquid like petrol or alcohol, the boiling point might differ. Okay. boiling point of water at normal atmospheric pressure. Remember this, the boiling point of water is 100 degrees Celsius when the pressure is the atmospheric pressure. If the pressure increases, so here, when does the bubble break? The bubble breaks when the pressure inside the bubble is equals to the outside pressure, and outside pressure is depending on this atmospheric pressure. If atmospheric pressure is changes, then the temperature at which the pressure inside the bubble will increases, the pressure inside the bubble equals the pressure outside the bubble will also vary. Okay, so when the pressure outside the bubble is changing, the boiling point will also change. Okay, so that's why the boiling point depends upon the atmospheric pressure. If the outside pressure is increased, then boiling point also increases. If outside pressure decreases, then the boiling point also decreases. So in industrial applications, we are using boiler. So in this picture, you can see boiler in which the water may boil at a very high boiling point. The pressure inside this boiler is very high. We are constructing this boiler in such a way that the pressure is very high, so that the boiling point is also very high, like 400, 500, 600 degrees the water will boil inside this boiler. Like in pressure cookers, this we use for cooking in our household application. Usually the boiling point will be about 120 to 130 degree in a normal pressure cooker. Okay, so we are increasing the pressure to raise the boiling point of the water. But once boiling got started, no further rise of temperature is seen, though we are supplying heat. Why? So here, as we are supplying the heat energy, the temperature slowly rises to 100. But hereafter, we cannot see any change in the temperature. And where does this heat gone? See, we define boiling as the conversion of liquid phase to the gaseous phase. So the phase is converting from liquid to the gaseous. So at this point, the water reaches 100 degrees Celsius and the water has to convert to the gaseous phase. So it needs to change the phase. To change its phase, the water requires additional heat energy, and once the heat energy is supplied, it changes its phase. Okay, so at 100 degrees, the water starts boiling. So it needs to convert to the gaseous phase. When it will convert to gas, after absorption of some heat energy for the change of its phase. Once that heat is absorbed, the water will convert to the gaseous form. That heat you may call as latent heat of vaporization. See, I want to tell you one more time that when water is reached 100 degrees Celsius, it won't convert to gas directly. It needs some more heat energy. When that heat energy is supplied, then that water will convert to the gas. So at boiling point, water needs additional heat energy to convert it into a gas. That is what we call as latent heat. So latent heat is the heat energy required to change 1 gram of liquid to gas at constant temperature. That is what we calling as latent heat of vaporization. So here, what is this constant temperature? This is nothing but boiling point of the liquid. So here, boiling point of water. When water reaches boiling point, when we supply latent heat, the water will convert to the gaseous phase. So latent heat is given as latent heat L equals to Q by M, where Q is the heat, M is the mass. And what are the units for latent heat? In CGS, for heat we have calories and mass we have grams. So calorie per gram is the unit for latent heat. And in SI system, joule per kg is the unit for latent heat. The boiling point of water at constant atmospheric pressure is 100 degrees Celsius, and in kelvins it is 373 Kelvin. And what is the amount of heat required to change its phase? That is 540 calorie per gram. Okay, at 100 degrees, for each gram of water, we need to supply 540 calories of heat so that the water will convert to the gaseous phase. And this heat is at the normal atmospheric pressure. Okay, normal atmospheric pressure. So once the water reaches 100 degrees Celsius, if we supply 540 calories for 1 gram, then so this is the 540 calories of heat. Once it absorbs that 540 calories of heat, what happens? Here it is water. Okay, water at 100 degrees boiling point. When it absorbs 540 calories of latent heat, and at this point it will be converted to the gas. Okay, once the latent heat is applied, it will be changes its phase. Boiling point increases with increase in pressure. Latent heat of vaporization decreases with increase in pressure. So if we raise the pressure, there are two advantages. If we increase the pressure, the boiling point will increase and the latent heat decreases. This is an advantage to us. Okay, we can save the fuel for generation of the steam. So for example purpose, I have taken the boiling points and the latent heats at 1 atmospheric pressure and 2 atmospheric. This is for water. Okay, the boiling point of water when atmospheric pressure is 1 is 100 degrees Celsius, and at this pressure the water requires 540 calories per 1 gram to convert to gas. I want to remind you one thing. This heat is supplied when the temperature is boiling point. Okay, when the water temperature is at its boiling point, it requires 540 calories of additional heat to convert to a gas. And if it is 2 atmospheric pressure, the boiling point increases to 120 degree and the latent heat drops to 525 calories. So in 2 atmospheric pressure, if you supply 525 calories of heat to the water at 120 degree, then it will convert to the gaseous phase. Okay, this is a very important consideration for thermodynamic engineers. So there is a need to decrease the latent heat for consumption, for saving the consumption of fuel required. Okay, so for that reason we are constructing boilers which will raise the pressure, hence the boiling point increases and also the latent heat will decreases. Guys, I hope you understand the topic of boiling and latent heat of vaporization. If you are having any doubt, please just let me know in the comment section. And in the next class, I will take an example on latent heat. Guys, please subscribe to my channel. Do like the video and also share the video. For new notifications, click on the bell icon. Thanks for watching.